get started here, Sami? Okay. Thanks, everyone. Today, we're going to talk a little bit about what is driving some of the dependencies that might show up in the future between the system BIOS, the firmware, and the BMC firmware, right? So let me give you some background in here. So a lot of runtime RAS features, the BIOS, is basically being done by system management mode, SMI, right? And it's creating a lot of scaling issues where we cannot scale with core count. It is creating a lot of performance jitters, right? So there is an industry-wide push in basically migrating some of these features to the BMC, right? So we call it RAS offload. So a lot of these features that were until now done by the system firmware, the host BIOS in runtime, they are slowly getting sort of migrated to the out-of-band system agent, right? The BMC. Now, if you think about it, not just RAS, but anything that can be handled in runtime in the host is slowly getting migrated over to the BMC. So if you basically think about it, in the future, as we deploy these solutions in the fleet, we'll be running into a lot of logistical issues, deployment issues, right? So I would say until now, the BMC firmware is pretty agnostic to the silicon, very agnostic to the SoC, right? And so it doesn't really care if there are silicon-specific knowledge that it needs to be, part of the BMC firmware, or if we go and say refresh the SoC or put a new stepping in, BMC firmware doesn't really care, right? But now as we go into this model of moving all these features into the BMC, now you just imagine the scale of the problem we're going to face as we go. So any small change, a workaround, or could be a stepping change, or a refresh CPU on the same platform, the BMC has to get updated, right? And the BMC also needs to carry intimate knowledge of the silicon specifics, which is pretty complex. Some of the things that the BIOS has been doing has now the whole knowledge has to be shifted to the BMC as well. So these are some of the challenges that we'll be facing with the migration of the features to the BMC. And we're also going to talk about a case study, right? Memory address translation. So when you think about RAS features, typically there'll be, error collection and reporting for correctable errors, and some corrective rash actions that we can take. If you have memory correctable errors, PCI correctable errors, we get a SMI typically, or an SCI, an interrupt to the BIOS. BIOS handles these things, goes and harvests those errors, and then takes corrective actions. Maybe it could be some RAS action like sparing and things like that, right? Or these things are slowly getting migrated to the BMC. A lot of CSPs that are coming to us and saying, can you guys give us a solution where we don't need to rely so much on SMI and migrate these things to the BMC? So that work is happening right now. Also, non-RAS uses as well, right, that we can think of moving into the BMC. So today, if you look at UEFI runtime services, where we expose get set variables, so we're going to write to NVRAM space. And that invokes SMI today because NVRAM is sort of protected in the sense that you don't want, corruption to happen in NVRAM, so we funnel this through SMI mode. So that can move out to the BMC as well. So basically what we're doing is taking the get set variable interfaces, the UEFI interfaces. The interface to the OS will remain the same, but underneath it, instead of funneling it to the SMI, we can reroute it to the BMC, and BMC becomes the repository for the variable store, right? So that gives us a little bit of a complexity there, because now the BMC has to understand how the variables can be managed, dependencies between the different variables, what could be the range of a given variable, right? All these things the BMC has to know. So how do we transfer the knowledge from the BIOS to the BMC? So let's take a look at a case study in here, right? So I just talked about the challenges posed. I don't want to rehash the same thing in here. Typically, what happens is, if I'm going to take an example of the RAS code I'm going to talk about, I want to convey or pass that information to the BMC. But what we do today is we take the BIOS source code, we extract the runtime portion of it by hand, and then copy it into the BMC source code and recompile it for the BMC. So it's a manual process. And every time I need to go modify something, I have to go do the exact same manual process. And every handler has to be written twice, one for in-band, one for out-of-band. And it's a very inefficient use of resources, right? And as you said before, this tightly couples the BMC to the SoC. So any fixes, any updates, then we have a scaling problem to deploy it at fleet. So this basically reiterates what I just said. Basically, I take the source code and then go to a manual process of extracting the source code from the BIOS tree and then pasting it into the BMC's firmware image or firmware source, and then recompiling it to the native instruction set for the BMC and giving it to as a BMC firmware, right? So I just want to take a case study of address translation. So when I say address translation, it's a critical RAS feature that server class platforms typically have. It is basically used for identifying a faulty DIMM, right? So if I get a machine check, for example, and I read the address of where the machine check happened, I want to map that address, the system physical address, to the actual corresponding DIMM location to identify which DIMM actually failed. So that is an algorithm that you have to run through to basically read all the system decoders and figure out how that whole thing translates to. So these things are getting more complex as we have more interleave schemes, pneumo domains, we have multiple sockets and things like that. So basically, just to picturize it, on the left, you have the system physical address space, right? The entire memory address space. And if, let's say, SPIX is the address where an error happened, now I need to go and convert to find out which socket, which CPU socket in a multi-socket system this address falls into, and from there, which IMC it falls into, which memory controller it falls into, and within the memory controller, which rank or which channel it falls into, right? So it's a pretty complex algorithm that we have to run. And the BIOS knows inherently, because BIOS is the one that programmed it in the first place. So BIOS knows inherently how the system address map is set up. So this address translation happens when I get an error and I want to find the DIMM address, or vice versa. So this model is to have the BMC do this is going to be a pretty heavy lifting, right? So we basically are looking into one model like this. The other model is for UEFI runtime services. Again, we are moving to the BMC, and that also creates a lot of complexity from the BMC firmware perspective, where it has to know tightly understand the platform topology, understand the dependencies between different UEFI variables and all the associated parameters and things like that. Even if you go with authenticated variables, the BMC has to understand that as well, right? So we have a solution space that we are looking into right now, but where I want to go with this is, have a discussion along the OSF members in here and see if this is a solution or a problem that we're going to face in the future if if something that we need to focus on right now, so we don't have this hurdle as we go in this direction, right? So we do have some POCs at this point, but it is too early in the process to dwell too deeply into solution space right now, but we can talk offline if you guys are more interested in that. But it is a couple of ways we can do this, and keeping the BMC agnostic to the SoC and to the platform, right? So the solution space is getting little trickier, but we are looking into it from multiple angles. How to make the BMC completely agnostic and have the BIOS provide some sort of modules to the BMC as it boots. So the BIOS carries all the knowledge and then transfers over to the BMC. Right? That's one way to do it, but the POC is going on, and I'll give an update as soon as we have some line of sight on that. But I just want to put this out to the community in here to basically see that there is going to be a hurdle coming up soon as we go in this direction, and how do we go solve it right now. Right. So I basically want to have some sort of a mind share around this problem here, and how can we keep the BMC agnostic, but then still carry all the features, and it still can do RAS, it can still do UFA variables, but keep the BMC firmware agnostic to what's happening on the host side, and how we can sort of migrate this knowledge over to the BMC. So I think it's going to be a very, very short presentation on this one, because it's mostly a problem statement and sort of a solution space, but I just want the community to get together and work towards the solution in this one. So I'll open the floor for any questions or suggestions here.
Hi, I have a question, or actually more like a thought. So regarding this SPA to DPA translation, this is a real problem, I think. And have we given any thoughts regarding like various kind of algorithm or translation into the hardware? Like today, for example, when error happens, machine check does report this SPA or address in the machine base, right? Mm-hmm. And anything can be done at a hardware level to further translate this into like a full isolation kind of schema here?
Yeah, I mean, this is a good question, a little tangential to the discussion here, but at this point, we don't see any hardware that can do it without too much complexity, because if it's a multi-socket topology, and when you have things like XNCs, right, across nodes, so it becomes very hard for the hardware to go do this. It's much easier for the firmware which programs these registers, these decoders in the first place, to have that knowledge, because it can see the full topology of the platform, versus a hardware within one socket not knowing about the rest of the platform, right? So I think at this point, it's mostly a firmware-based solution.
So hardware is out of picture in the short term or mid-term here? So hardware is going to provide you in a machine check bank the system physical address, right? But translating that to a DIM address will be done by a firmware entity. Okay. Yeah.
One quick question.
Yeah.
Hi. You mentioned that one of the challenges was that SMI was not scaling up very well. Now that you went down this road of pushing RAS features into the BMC, is that scaling up very well?
So that is one path we have today, right? That could be in-band paths as well. Natively, we can handle a few things in the OS. We also have PRM that some of the things can go in that direction. But if you look at hardware events that trigger let's say an error event triggers an interrupt to the in-band host, or it can trigger an out-of-band pin, like error pin to the BMC. And the BMC can go and harvest these errors, out of band and handle in its own way. And it can also report out of band to the manageability side of the house. So I think the scaling is mainly because if you do SMI, you are taking away CPU cycles. The host cycles are gone, right? And there's a performance impact because you take all the threads into SMI. So I think it doesn't scale with core count in that aspect.
But is the BMC becoming a bottleneck there?
That's what we are trying to figure out. So the BMC might, at this point, it looks promising. We are still doing some analysis on whether we can do, how fast we can collect errors if there's an interrupt storm and things like that, right? So it all depends on, what is that little, bandwidth the BMC can provide to the.
Thank you.
Yeah, thanks. Any more questions? All right, thanks everyone. Thanks.